Good day to Dr. Amri and my fellow friends. We are from SKEE2133 Section 1. In this video explains about Experiment 1, Electrical Measurement. So, my name is Samuel Ng, this is me, and my group member is Terence and Dua Jayal. So, without further ado, now I will explain about Part A, which is the voltage and current measurement. So the apparatus needed for Part A are a digital multimeter, an analog multimeter, wires, a breadboard, power supply, and a few resistors which include 100 ohm, 150 ohm, two 330 ohm, 1 kilo ohm, and a 39 kilo ohm resistor. As you can see here, these are all the apparatus needed for Part A. So in this clip, we are measuring all of the resistors value so that we can start to build the circuit. Now we connect the power source to the breadboard to power up the circuit. So now we are testing whether the circuit is functional or not. So this is our final circuit for Part A. As you can see, we connect the red wire to the positive terminal of the power supply, and we connect the black wire to the negative terminal of the power supply. After that, we connect a 330 ohm resistor to the positive side of the power supply and connect it in series with another 330 ohm resistor. After that, we add another 100 ohm resistor in series with them. After that, we also add a 1 kilo ohm resistor in between the two 330 ohm resistors. Note that the 1 kilo ohm resistor and 100 ohm resistor are connected to the negative terminal of the power supply too. Now moving on to the measurement part, we use both a digital and analog multimeter to measure the current and voltage in each part of the circuit. For the ammeter, we need to connect it in series with the circuit, and for the voltmeter, we need to connect it in parallel with the circuit. So firstly, we use the analog multimeter to calculate the value of IA. In order to do so, we need to open circuit the 330 ohm resistor and connect the multimeter in series with the circuit. So this is the value we got, which is 14 milliampere. So now we use a digital multimeter to measure the value of IA as well. So we need to open circuit the 330 ohm resistor and connect the multimeter in series with the circuit. As you can see, the value we got is 14.54 milliamperes. So we need to repeat these steps throughout the whole experiment until we get all the values of IA, IB, IC, and VA and VB. So this is the results we got for all the values using the analog multimeter. And these are all the measurement values we got using the digital multimeter. So moving on to the next part, which is Part B, we will perform the resistance measurement using Wheatstone bridge. So the apparatus needed for Part B are digital multimeter, analog multimeter, wires, breadboard, power supply, potentiometer, and 150 ohm, 330 ohm, and 39,000 ohm resistor. So now we measure the resistance of the potentiometer. The minimum resistance of the potentiometer is 1.8 ohm, and the maximum resistance of the potentiometer is 24.93 kilo ohm. So this is the tip of us building the circuit. This is the final circuit for Part B. As you can see in the red circle, the potentiometer is connected to the circuit through the wires. So this is the complete circuit of Part B. So now the knob of the potentiometer is turned until the bridge is in balance condition, where the digital voltmeter shows 0 volt. At balance condition, we measure the resistance of the potentiometer using the digital multimeter, which shows us the value of 17.68 kilo ohms. So now I will conclude the results we got from Part A and Part B from our experiment. So this is the result for Part A, which consists of all the measured values of IA, IB, IC, VA, and VB using analog multimeter and digital multimeter. It also consists of all the percentage errors for all the measurements. And this is the result for Part B, which we calculated the resistance value of the potentiometer using the digital multimeter. So moving on to the discussion of our experiment, the digital multimeter gives a more accurate and stable reading as compared to the analog multimeter. It displays value with decimals, making it easier to get precise results. In contrast, the analog multimeter shows approximate values using a needle which can be affected by parallax error. During the experiment, the digital multimeter provided quick and clear measurements for voltage, current, and resistance. The analog multimeter needed more attention to use correctly. Overall, the digital multimeter is better for accurate and efficient measurements, while the analog multimeter is helpful for visual monitoring of changes. So that's all from our group. Thank you.